So we are being recorded, and I think the volume is actually turned on now, so you don't have to do it. All right, so tell me something. What is factoring? What are factors? Back to the basics. Like if I give you the number 10, what are factors of 10? 2 and 5. And 1 and 10, right? 1 and 10 can multiply, 2 and 5. Okay, so we're going to do that same thing. We're going to break it down into these two numbers that multiply to equal, and we're going to do it with polynomials. Okay? So factoring, we're going to start with the final answer, and we're going to break it down into the basics. So the Roman numeral 1, the first thing always, no matter what size the polynomial is, the very first thing you always do is the greatest common factor. Okay, what do they have in common? You're going to pull that first. Doesn't matter what size the polynomial is. Okay. So, for example, let's say I give you 4x squared y plus 32x y to the fourth. So we look at the numbers, we look at the greatest common factor of 4 and 32, we look at the x and the y, and what do they have in common? What's the greatest common factor? So 4 for the number. Now the trick for the variables is simply take, as long as there's an x in all of them, take the smallest exponent. So in this case I have x squared, I have x to the first, so the smallest exponent is 1. So I'm going to take x to the first. How many y's will I take? 1, because this is y to the first, this is y to the fourth. You take the smallest, so it's y to the first. Okay? So then, it's like dividing. It's like you're taking this and dividing by 4xy. Factor means we're kind of, if we go back to my example here, if I have 10, I know 2 goes into it, so if you take 10 divided by 2, you get 5. So the same concept here, you're dividing it out. So then what do I have left? If I take 4xy out of 4x squared y, I'm left with just the x. Because the 4's cancel, the y's cancel, and you just have an x. Whoops. X. Plus, if I take 4xy out of 32xy to the fourth, what do I have left? Say it again. Not 6. Eight, y to the, not fourth, but third, because there's 1 on the bottom, right? So you take that 1 out, so now you're left with 3 of them. And there's your greatest common factor. Okay? So that's always the first thing we do. Take out the greatest common factor of numbers, and then take out the lowest exponent of the term. Okay? Make sense? Look at it with a high common.
I had to look at more.
You're fine. Okay, we're good with that? First thing you always do whenever I give you a factoring problem, always look what do they all have in common. It's the first thing you start with. Alright, try this one. Here's an example. Let's make this a little bit more difficult. Let's go 6x to the fourth y squared minus, let's go with 15x to the third y to the fourth. Factor out. First of all, let's start with what do they have in common? Okay, so between 6 and 15, what's the least common or the greatest common factor? 5 does not go into 6. 3. 3 goes into 6, twice, 3 goes into 15. So if you get stuck, start looking at 6, start writing down the factors 1 and 6, 2 and 3. Look at 15, start writing the factors down 1 and 15, 3 and 5. Oh, there's common, that's the biggest one. Okay. So factor out that 3. Okay, how many x's am I going to factor out?
3.
Why?
the lowest one, right?
Yeah, we have x to the fourth, we have x to the third. It's the lowest exponent, so x cubed. Here I have y to the second and y to the fourth. So I'm going to take Messiah. What's the lowest exponent for the y's? 2. So I'm going to take out y squared. Okay. So then what am I left with? So you don't have to write it. In fact, I'd encourage you not really to write this, but you have to think this way. 3x to the third y squared. 3x to the third y squared. And then what do we have left? Are you guys warm in here? Okay. Comfortable? So I can just turn off. Okay, so then what do I have left here?
2x minus 5y squared.
Exactly. 2x minus 5y squared. Got it? Okay? Yeah? Ask now if they're going to. I'm just kidding. You can ask now or ask later. I just do it.
Where'd you get the 2x?
So we took out 3x cubed, y squared, so the y squareds cancel. 6 divided by 3 is 2. Because you have 4 on top and 1 on bottom, it cancels out 3 of them, you have 1 left. Same thing over here, the x's cancel. 2 and 4, you have 2 of them left, and then 15 divided by 3. Good question. Okay. Here's one, and it's going to give us a new definition. You may not have seen this before. But let's say I give you something like 16x plus 27y. What's the greatest common factor? You look like you have an answer. What's the greatest common factor? 3 does not go to 16.
6.
6 does not go to either one of them. Say again. What's that? 1, yeah. So if, here's our definition, if greatest common factor equals 1, then we call it relatively prime. These two numbers are relatively prime, means the greatest common factor is simply 1. There's nothing you can factor out or simplify as far as you go. By the way, when we are looking at factoring, that's what we want to get it down to where every factor is relatively prime. 5 and 2 are relatively prime. They don't break down at all. The greatest common factor is 1. So that's an example of relatively prime. All right, so the very first thing when the problem says, because I will not tell you on the Delta Math might, but when we come to a quiz or a test, I will not say factor using the greatest common factor. I will say factor. So you need to know the greatest common factor first. You're always going to do that first.
So does that mean like you just can't do it? What can you do?
You can't factor anything out of that. That is actually, they're relatively prime, therefore that is a prime number. Kind of like if I said factor out 19. What was in 19? That's it. It's prime. So the same thing here. This is relatively prime. You can't break it down any further. And that's our goal when it comes to factoring. We want everything down to part zeros. Okay, so the first thing we're going to do though is let's get the greatest common factor out.
Okay. So like when we ever have like a quiz on that, it's like when we go to stuff into
Yes. Or you can just put 1. GCF is 1. I mean, you can put either 1 for your answer. I don't think I'd give you that, but just so you know. Okay, now, so the first thing we do is greatest common factor. After that, there's not a step. You look at what they give you and then you decide what to do from there. Like for instance, if you're getting ready to come in and do a job, Do you grab a screwdriver or a hammer first? Depends on what you're doing, right? Trying to pound in a nail or hit somebody, you use a hammer. If you're trying to fix one on my desk, you use a screwdriver. Depends on what you're doing. What tool you're going to use. So from here on, it depends on what we have. Okay? First thing is greatest common factor. The second thing, Roman numeral 2, is what if I have two terms and only two terms? We would call that a binomial. What if I have a binomial? What do I do in that case? Well, there's only three options. And the hard part about this is there's no algorithm, no magic trick to it. You have to recognize and see. I have two terms. I have a binomial. So this is what I'm going to do. One of these three things. Okay. A, I have the difference. Okay, so if I'm looking at a difference, what operation do I look at? Not division. The difference is subtraction. So when I look at a binomial, for a difference of two squares, it needs to be a minus. Okay, so the difference of squares. Okay, so if there's two terms, it's a binomial. The first thing you look for is, do I have a difference of two squares? So we know difference is subtraction. What do squares look like? Well, we know that's 1, 4, 9, 16, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 100 squared, 11 squared, 12 squared, 13 squared, 14 squared, 15 squared. This has to be one of those numbers. So you're looking for a very unique number of perfect square. Okay? How do you know if a variable is a perfect square? What's the exponent going to be with a perfect square? Not square. What exponent do we have with things that are squared? 2, right? So anything that has a factor of 2. So your variable has to be even. So 2, 4, 6, 8, 10, 12 are all perfect squares. X to the 10th, X to the 20th, X to the 35th, not 30th, 36th. Anything that's even has a perfect square. Okay? So difference of squares. I know you've seen this before, so let's review this one. What if I give you something like 4x squared minus 9? 4x squared minus 9. So you have the difference, right? You have subtraction. I have 4, which is a perfect square, 9, which is a perfect square. I have an exponent of 2, so they're all perfect squares. So if you remember, we break this down into two numbers. The first number will be the square root of 4x squared. So what's the square root of 4x squared? 2x. So I have 2x and 2x. Okay. What's the square root of 9? 3. So 3 and 3. And then my signs, if you remember this, is 1 plus, 1's minus. And if we go back to what we did the other day, 4a, when we multiply, if you FOIL this out, you will get 4x squared minus 9. Now, here's another definition. We will come back to this, so we might highlight it, put a mark on it. We'll come back to it in a later lesson. There's a name for 2x plus 3 and 2x minus 3. Notice the only difference is the sign in the middle, right? These are called conjugates. Those are called conjugates. We'll come back to that. Like when we get to complex numbers, when we get to some rationals, we'll come back to this concept of conjugates. Okay. So how many of you remember difference of two squares? No? Kind of me? How many of you remember difference of two squares? You've seen this before? It looks kind of familiar? It's been a little while for you. Alright, try this one. Factor this one for me. Let's take 16x to the 4th minus 25y squared. 16x to the fourth minus 25y squared. Factor that one for me. Okay, Messiah, what's the square root of 16x to the fourth? Not 8. Not 8. It's not 2. What times what equals 16?
8.
Nope. 8 times 8 is 64. 4. What's the square root of x to the fourth? X squared. So I'm left with 4x squared. 4x squared. Okay, what's the square root of 25y squared? No. What's that? No. Just 5y. Because y squared is just y. So 5y. One's plus, one's minus. It doesn't matter which one's plus and minus as long as one's equal to each. Now wait a second. I see a binomial, right? I see a difference. That subtraction. Is 4x squared a perfect square? It is. Because 4 is 2 and x squared is 2. Is 5y a perfect square? No, so no. If that turned out to be a perfect square, we should be having to factor that as well. So difference of 2 squared. Anytime you see a binomial, look for difference of 2 squared. Okay, so we're good with it. Now there's no other way to do it. You just have to memorize it, you have to recognize and see it. And once you see perfect squares, one's plus, one's minus. But I told you how many possibilities are there with 2 terms? It's 3 possibilities. That's one of them. Part B is going to be the sum or difference. This could be a plus or minus of cubes. Okay, so what are our perfect cubes? 1 cubed is 1, right? 2 cubed is 8. 8, 2 times 2 times 2. What's 3 cubed? 27. 3 times 2 times 3. 4 cubed, 64. By the way, that's a unique number. It's a perfect cube and a perfect square. Okay. What's 5 cubed? 25. 6 cubed? 7 cubed? 8 cubed? What's 8 cubed? 516? $516? That's not right. $576?
What?
8 times 8 times 8?
512.
512?
512.
Okay, oh yeah. Okay, 9 cubed is 729, and 10 cubed is 1,000. So it's one of those numbers you have to recognize. Okay, what's a variable going to look like in a perfect cube? In a perfect square, the variable has to be even, so 2, 4, 6, 8, 10. What's it have to be with a perfect cube? Don't say odd. You're going to do your thinking odd, aren't you? I kind of set you up that way. This is even, so what do you think this one is? No, it's not odd. It's not even. Any idea? So what is the variable in a perfect square has to be even. So like x squared, x to the fourth, x to the sixth, those are all perfect squares. What's the variable have to be if it's cubed? No. It's not even either. It's not prime either. As soon as I tell you, it's going to make total sense. Okay. Say it again. No, that's right. It has to be divisible by 3. Because all of these are divisible by 2 squares. These have to be divisible by 3 cubes. Let's just divisible by 2. Now, the reason why this one is not remembered as much, in fact, I know you've had this, I've talked to your Algebra 2 teachers, and they all teach this. The reason we don't remember it is because there's a formula you have to memorize, you have to know it. Okay? So let me give you the formula, and then we'll show you how it works. Okay? So the formula is this. One thing you just need to know. I do think it might be on a reference sheet, but it doesn't say anything about it, so you just have to remember it. Okay, so if I give you something like x cubed plus y cubed, they're two, so you recognize them as two perfect cubes. It's like 64x to the third, or 125y to the sixth. So you recognize it as perfect cubes. The formula goes like this. It has a binomial x plus y, then it has a trinomial x squared minus xy plus y squared. And there's the formula. There's a couple ways to memorize it. Once you get the cube roots, then it's just x squared and y squared. Just multiply them together and put it in there. Let's see what this looks like with real numbers. Let's do one fairly simple. Let's do a cubed plus 8. Do you remember this? Okay. I had a pre-calc student not remember this, and a calculus student not remember this. So just one of those things that you don't really hit too hard on. So we looked at a cubed plus 8 is my example. Okay? So if I say you need to factor a cubed plus 8, okay? Well, the first thing is going to be, what's the cube root of a cubed and 8? Cube root of a cubed is, no, just a. Because a times a times a is a cubed, right? What's the cube root of 8? 2. So I'm just going to put a plus sign between them, a plus 2. Okay. Then, what's going to go first in this trinomial? Well, all you're going to do is take your first term a and square it. It's a squared. Then you have a minus. To get the middle term, you simply put the a and the 2 and multiply them together. A times 2 is 2a. Plus, and now we're going to take our last term, that 2, and square it. 2 squared is 4, and there's your factor. Some science that you remember that. Do you remember this at all? Vaguely? Do you remember this off like a year and a half ago? This is big, like, so almost 2 years ago. Do you remember this? Yes? Okay. You did do it last year. Everyone did it last year, except for people who didn't take math last year. Exactly. Okay, so the only difference is now, because I told there's 2, sum or difference, the only difference is, what if this is a minus sign? What if it's a cubed minus 8? The only thing that changes is the sign. Everything else is the same. So, I don't know how many remember this, but there's an acronym to remember it. The signs go same, opposite, always positive. So remember SOAP. Okay, when it comes to cubes, it's SOAP. Because a cube is in the shape of a prism, where a SOAP is in the shape of a prism, which is the cubic. However, you have to remember SOAP. Because it's the same, opposite, always positive. So in this case, you would still have a and 2, but if it's minus, you just bring that minus sign, it's the same. The trinomial is exactly the same, a squared, 2a, and 4. The only difference is this is the same, so this is the opposite, and the last one is always positive. And the only thing that changes between those two is the signs. Same, opposite, always positive. Sum and difference of cubes. Ready to try one on your own? Say yes. Absolutely. Fantastic. Let's come with one. Let's use some numbers we have over here. Let's go with 27 x to the third. Let's go with minus, how about 8 y to the sixth. 27x to the third minus 8y to the sixth. Try that. Start off by finding your cube roots.
Wait, that's a 2?
27x to the 6th. 8y to the 6th. There we go. So before we go too busy on this one, what goes in the first binomial? Three what? 3x minus 2y what?
Squared.
2y squared. Very good. You can take that and apply it to the trinomial. So what's going to go first? What's going to go in this first spot of the trinomial? Close. You said 3x squared? It's very close. Square the 3 as well. Square the 3. So it would be take 3 squared.
6. You said 3 squared.
Yes. Okay. No. Squared. No.
Oh.
You did 3 times 2. I was just like, what did you do? Okay. So it would be 9x squared. Because you take the 3x and square the whole thing. Okay? We know the sign in the middle here is going to be positive because it's the opposite. What's that middle term going to be? Say again? 2 9?
No. 2 negative.
Okay. Remember how we found the 2a, right? What did I do to find that one? I said we took the two terms and multiplied them together. So take your 2 terms, multiply them together. What's 3x times 2y squared?
Negative.
6xy squared. You don't need to worry about the signs. You don't need to worry about the sign because we know it's going to be positive. So you literally just take 3x, 2y squared, and multiply them together. 6xy squared. Then what's the last term going to be? You're going to take 2y squared and do what to it? 4y to the it's y squared squared.
Yeah.
Y squared squared. Four. Y squared times y squared is what is it? So you take 2y squared squared. Here you take 3x squared. And in the middle you just take the 2 and multiply together. Yeah? Does that clear a few things up?
I see.
That clear a few things up? Yes? Alright, you good. How much scribbling there at the bottom? That one you will definitely want to practice on. But here's the thing, when it comes to delta math, when you start practicing, you just have to recognize it. You have to look at it and say, okay, there's only two terms. I start off with binomial. Are they squares or are they cubes? You just have to recognize that. Okay, you got it written down? Say it again. One more time. Because then we're going to Roman numeral 3, looking at 3 terms. I'm trying to get through that before we go. Say what? About 9.5 minutes. I think we're out here 11:50. So. What? Yeah. Okay, we good? Okay. So we'll come back. If I were you, I'd put maybe a little star by that one and say I need to go over some of those practice problems. Okay. Number 3. So the first one was we always do the greatest common factor first. We bring out that one term. Roman number 2 is if there's 2 terms, if it's a binomial, it's going to be one of those 3. Sum of difference of cubes, difference of squares. One of those 3. Number 3, if there's 3 terms, so you have a trinomial, there's 2 different types. The first one is where a equals 1 is what mathematicians call it. It's where a equals 1. These are the easiest ones we factor. Most people remember how to do these. It may just take a second to catch up. But like x squared plus 7x plus 12. And I ask you to factor that. So what 2 factors are we looking for? Numbers that do what? Multiply to equal, no, the third term. So multiply to equal 12 and add to equal 7. So what are my 2 factors? Multiply to equal 12, add to equal 7. It is. So what are my factors of 12? We have 1 times 12, 2 and 6, 3 and 4. So 3 and 4 is my answer because that equals 7. Okay? So I'm going to have x plus 3 and x plus 4. So it's just simply what multiplies is equal to constant, what adds is equal to linear. So let's say I give you x squared plus 5x plus 6. It is. Look at your 6. You have 1 and 6, 2 and 3. So it has to be x plus 2 and x plus 3. Remember doing those? Those are the easy ones, typically. Typically, those are the ones in Algebra 1, Algebra 2 we do okay with. Where we start running into problems is in letter B. I want to spend a little more time on this. We may have to go into next time. But that's where A does not equal 1. Where A is something else other than 1. So like 2x squared. Make sure I write this down correctly. Plus 5x minus 3. So now we can't just do what multiplies equal 3 and adds equal 5 because that 2 messes everything up. That number out front, that A, screws it up. So your teachers have probably taught you different methods. There's a method called grouping. There's a method called bottoms up. There's a method called the star method, the box method. I like to just do it in your head method, personally. But there's lots of ways to do it. So I'm going to show you the way I would do this one. And then I'll show you the bottoms up or the impossible math problem way to do it. Okay. So the first way I would do is I know there's going to be 2 factors. And I know the first 2 here are going to multiply to equal 2x squared. So what do they have to be? Well, one has to be x and one has to be 2x. So I have to have 2x and x in it. Okay? Now, because this number here is a negative, -3, what's that tell me about the 2 signs? They're different. One has to be positive, one has to be negative. And because it multiplies to equal 3, there's only two options, right? 1 and 3. So it's either going to be positive 1 and negative 3, or it's going to be negative 1 and positive 3. So then you just kind of do it in your head, kind of figure out, okay, well, I've got to get to 5. So I know if I put 3 here, 2 times 3 gives me 6. That's pretty close to 5. So then the 1 would go here. That's going to give me 5 and 1. That's going to equal, or 6 and 1 is going to equal 5. Then I just simply look at, I have to have a positive 5. So the bigger number is going to be positive. If I check it, 2x and 3 gives me 6x. Negative 1 and x gives me negative 1x, which combined gives me 5x in the middle. And the more you do it kind of intuitively, think it through, like for instance, if this is a negative, you've got a positive and negative, this one's positive, the bigger one's positive. If this one was negative, the bigger one would be negative. You kind of check and see those type of little tricks to it. But let's go through the way you probably learned if you learned it here at school. I know Ms. Gravina, Mr. Franco, I think, I don't know what Ms. Ortiz did, but a lot of them will do the bottoms up thing. Okay, so let's walk through that one. So if I have 2x squared plus 5x minus 3, the first thing they taught you was we don't want the 1, we want a 1 to be here. So I want to get rid of this 2. So let's just bring the 2 and multiply it by the 3. So we have x squared plus 5x minus 6. You simply take the a and multiply it by the 6. And then you can factor as normal. X and x multiplies to equal negative 6, adds to equal 5. Well, you know you're going to have 1 plus, 1 minus. So what multiplies to give us 6, adds to give us 5. Multiplies to equal negative 6. Well, if I have 2 and 3, I'm going to have positive 2 and negative 3, and I have a difference of 1. So it can't be 2 and 3. Say it again. Multiplied equals 6. So it's going to be 6 and 1. And the bigger number is going to be positive. So it's going to be x plus 6, x minus 1. But that's not the same. That's different numbers, right? Well, remember I multiplied by 2. Okay, so I have to go back and undo that. So since I multiplied by 2, I'm going to have to divide by 2. So you divide these two numbers by 2. I multiplied the constant by 2, now I have to divide the constant by 2 to take it back out. So this is going to be x plus 6 divided by 2 gives me 3. And this is where the bottoms up comes in. You bring the bottom, since they don't reduce, you bring the bottom up, and you get 2x minus 1. There's lots of ways to do it. Some of you may have learned. I have a star method. I've got a box method you could learn. There's lots of ways to do it. Tic-tac-toe. When I did algebra, I used to call it teach kids the tic-tac-toe method. So practice this one. Go back and review this method. Factor these out. If you need another algorithm or another step-by-step, be glad to show it to you. Whatever you used to do, we'll do it. Okay? Does that make sense? Okay. I do have Roman numeral 4, and the other class got to it. We're not going to because we have 2 minutes left to go in class. We are here at 11:50, right? Yep, lunch 11:50. So we'll have to pick up with Roman numeral 4 on Wednesday. So
Wednesday or tomorrow?
what class is this? This is 5th, tomorrow. So we'll pick up with it tomorrow and finish. Sorry. I didn't even talk to you. I'm still not there yet. So we'll pick up with 4 tomorrow, finish it up, and then we'll come to Monday. So factoring is the one very, very important thing we'll be using this all year. So make sure you practice it and do it. In fact, I think on Thursday we're going to do a day of all just factoring. Play a little game and do just factoring.
We come back after lunch, see?
You do not. Today is Monday, so you do not come back after C.